All right, transformations. Next chapter, so we're in chapter 2. Transformations. We're going to skip over this rather quickly. Transformations are going to result in translations, reflection stretches, and combinations of these. So we have the search thing we had before, where we go stretch, reflect, and translate. That's the same thing we're doing now, and do them in that order. So we get this big, ugly thing right there. And this, by the way, this K and this K are the same K. I'm not sure why they draw it like that. We can just move that K on either side, depending on, you have to get used to it being on both sides. So this is going to be, the K is going to be a vertical change. A is going to be vertical, and your B and your H are going to be horizontal changes. Okay, whether we stretch them or translate it. Okay, so the first thing we're doing is talk about translations, which is just the slide moving left to right. We're not stretching anything, we're just going to take this and move it left to right or up and down. So what I really need you guys to be, we have not seen the K over on the left-hand side of the Y before. In grade 11, we didn't do that. I did mention it, I remember talking to you, but notice it can go to here or we can move it over and go there. So the difference is you have to know when is it the opposite and when is it the same. So we go down here and we look at this x squared stuff. We've seen all these parabolas before, and we know what happens. So y equals x squared will be centered right on, that's what we have in this picture. I'm not going to go through these, but this one here is going to go 3 places.
To the left.
No, not to the left, because it's with the y. So since it's with the y, it's going to go up or down, and it's going to go 3 places up. It's going to be equivalent to saying this, y equals x squared plus 3. That's what you're used to seeing. See how the 3 can go easily to the other side? So we're going to go 3 places up, okay? This one, the y plus 3 equals x squared, is going to go 3 places down, because it can be easily rewritten like this. That's what you're used to seeing, and it takes it 3 places down. So we're going to go down here. I'm not going to graph them or fill them all out. You can do it if you want to, but right here, it says on letter C, in the second table, y has been replaced with y minus 3. What is the effect of this replacement on the graph of y equals x squared? And we just said that this translates 3 units up. And similarly, when we go replace y with y plus 3, this translates at 3 units down. Yes, ma'am.
Can we just automatically
You can.
so that
You can, although you're going to get used. You're going to need to get used to seeing it on the other side, because they're going to do a lot of that. But you can move the 3 over if you want to. Yeah. Okay, turn the page. All right. So here it wants us to do some more investigations, similar things. Really important to note, if it's with the x, we go left and right. If it's with the y, we go up and down, right? If x's are left and right, y's are up and down. So if we were going to graph this really quick, y equals absolute value of x, we know it looks like that. If you put arrows on those, they go forever. And then if you go y equals absolute value of x plus 2, we know what happens to that. No, it goes up 2 because it's over there. I know, so you have to keep it straight. Which side is it on, right? So this is going to go up 2 like this. Okay, and this one is going to go down 3, like that. So you have to keep it straight what side of the equation it's on. Well, so for example, this plus 2, when it's on the right side of the equation, you do what it says. When it's on this side, like this, you have to do the opposite. You know what I'm saying? So it really depends on which side of the equation. When it's all here, that's already been moved. It's already been done the opposite of. It used to be over here, in which case I would do the opposite of plus 3, which is down 3. With me? Yes. Oh, they've already moved it to the other side of the equation, so now I'll just do what it says. Okay. So we can go on down here and say, how does it, so here they put it back over, because they're trying to get it through your head. that when you replace y by y minus 2, you actually go up 2 units. Whoops. And when you replace the y with y plus 3, you actually go down 3 units. You're trying to get that in your head. They're trying to get you to replacement. We're going to talk about replacement notation. Okay. So it says, using results of what we just did, what is the effect of the parameter k when it's on the right-hand side? So what they want to know is, okay, well, k, first of all, it's vertical. Okay, vertical translations. And I'm going to say, when it's on the right-hand side, well, maybe I'll just leave it right there now. Now it says, what is the effect of the parameter k if it's on this side? Does it matter which side it's on? No, it's still vertical translation. What matters is where, like which direction, whether you're going up or down. So down here it says, okay, when I put the k on the left-hand side, it says compared to the graph of y equals f of x, the graph of y minus k equals f of x results in a translation of k units. So we're going to put vertical there. And we're just going to go k units. If k is greater than 0, okay, so this is the tricky part. And in the end, you're not going to have to know too much. It'll get clear to you. But if k is greater than 0, let's pick like 3, for example. Pick a value like 3. So if you had y minus 3 equals f of x, it moves it which direction? Up 3. If k is less than 0, let's say minus 5, for example, then we would have y minus a minus 5. What would that actually, would that take it up or down? It's going to go down, because this is going to go into y plus 5 equals whatever, and we would do the opposite of that plus 5, which is to go down. Okay? Okay, it's a little bit confusing with that. I think it'll make more sense when we actually go do some questions. It won't be as confusing as that little thing makes it look like right there. Okay, the notation y minus k. This is why, and I don't mind talking about that because those are some notation things you're going to get on numerical response. And they're going to say, what is the value of k if you have y minus k? And you're going to have to decide whether it's positive or negative. So it's not all bad to read that. So it says the notation y minus k equals f of x is often used instead of putting it on the right-hand side. To emphasize this is the transformation on y. Okay? The concept of replacing y by y minus k will be very important in this course. So get used to it being on the left-hand side instead of on the right. Okay, let's go on. Okay, so that was up and down. Now we're going to go left to right. And that's going to be evident because the x is going to be replaced with x minus h inside the parentheses. So that's going to become more clear to us. So see, this minus 3 could not be easily thrown over with the y. So it is not a change on the y, on the vertical. This is a change on the horizontal, this x minus 3. And this is going to go 3 units. This will be easy. This is what we always are used to. This is 3 units which direction? 3 units, no, to the right. And this is going to be 3 units left. So it's opposite, right? And so we could do all those pictures. I'm not going to. I'm going to go right on down here and say when I replace x with x minus 3, I'm going to go 3 units. So it's a horizontal. You can write the word horizontal. Horizontal translation, 3 units. That's being really 3 units to the right. And when I replace x with x plus 3, I'm going to the horizontal translation. I'm going to start putting HT, that means horizontal translation, and I'm going to go 3 units left. Okay? All good to go? That's exactly the way it was when we did quadratics. Okay? You always do the opposite of what was inside the x. Okay, so all of these things down here, this parameter, this value here, they're all going to cause horizontal translation. That's all we need to put in here. So this is a horizontal. Compared to the graph of y equals f of x, the graph of y equals f of x minus h. So it's a horizontal translation. Now let's talk about values. When does it move to the left? When does it move to the right? So if you choose at h greater than 0, so I would pick a number, 7. What would happen to the graph? Well, I would have y equals f of x minus 7, which moves me 7 units which direction? To the right. Exactly. And if you picked a number less than 0, let's choose negative 3, then I would have f of x minus a minus 3, which is where you get the f of x plus 3, and we know that would move it 3 units to the left. Correct. Okay. All right. Turn the page. So here, it's going to start talking about replacement. A lot of replacement stuff. So again, they're just wanting to emphasize that you're going to replace y with y minus k. That's going to be k units up in a vertical translation. And when you replace, I guess if k is greater than 0. Okay, and it's the same as when we kick the k over. Okay, that's always this is just saying what we just did. The only thing is that k being negative, if k is greater than 0, then it goes up. If k is less than 0, it goes down, etc. So let's just go here. I think we'll know. If you replace x with x plus 2, we're going to go 2 units, which direction?
Left.
Left. And if we replace y with y minus 8, we're going to go 8 units up. Exactly. Okay? Describe how the graphs are the following. Okay, here we go. More of the same, just different notation. So here we replace x with x minus 3, and we don't really care too much. We know it's going to be with the x value. Let's put horizontal translation. We should be saying that. Horizontal translation, 3 units, which direction? Correct. To the right.
Is not squared.
The horizontal translation, we're affecting the x value inside that function. This x minus 3 is being affected compared to y equals f of x. Right? The x is being replaced with x minus 3, so that's 3 unit translation to the right. Okay, what's happening in letter B? Well, actually, we know where it's going, right? If we want to talk about replacement right here, we know this is a vertical translation. 4 units, which direction? Up. That one's easy. That's what we're used to seeing. That's how we saw it all last semester. Okay, letter C. Both. We have a vertical and a horizontal. Let's name horizontal translation first. Horizontal translation, 10 units, which direction?
Left.
Left, correct. Now we're going to do a vertical translation, 1 unit, which direction? Up. Up. Yes, up. Okay, now we're going to do the same thing. We're going to carry on, but now we're going to talk about it being a point. So we just get a bit more specific. So we're going to take a point, 2 and negative 3, and we're going to say that lies on the graph of y equals f of x. We're going to state the coordinates of the image of this point under the following translations. Okay, so something the book does that I think you should write down, I think it'll be good, is they say y got replaced with y plus 8. They just make that little thought process in your head, which means it went 8 units where? Down. Correct. So we're going to take our 2, negative 3, and we're going to go 2, and this negative 3 is going to get taken down 8 units. So you can literally go negative 3 and then subtract 8. So that becomes 2, negative 11. Okay, 2, negative 11, right? Do you see? Okay. On B, it says y equals f of x minus 7 plus 5. So we have two things happening. So the book likes you to write this down. Y got replaced with y minus 5. They take that 5 and they put it over with the y. And then x got replaced with x minus 7. So now, oh, sorry, I wrote 5. So now what they want you to say, oh, okay, get this all written down, and now go tell me what happened. So this means I went, the y means I went, I'll use a different color, 5 units where? Right, so 5 up, and x minus 7 went 7 to the right, correct, 7 to the right. So we're going to add 5 and we're going to add 7. So our little point, 2, negative 3, is going to become 2 plus 7 and negative 3 plus 5. Keep the x's with the x's and the y's with the y's. And so you end up having 9 and 2 as your final answer. Yeah? Is that becoming more clear? I think it becomes more clear the more you do it.
Why the 2 plus 7?
Well, because I'm going to the right 7. I could actually say plus 7, like that. Right, I'm moving to the right, and I'm actually moving plus 5. Does that kind of make sense? Okay. Now it says, class example 4. Write the equation of the image y equals f of x after its transformation. I actually kind of think this is kind of fun, this part. So 5 units to the left is going to become, that's a horizontal movement. So it's going to affect the x. So I'm going to say y equals f of x plus 5. Correct. Okay. Translation of 3 units up.
Y minus 3 equals f of x.
Okay, so there's 2 ways to write this. You can go y equals f of x plus 3, or you could write it y minus 3 equals f of x. You with me? Either way. All right, so if we're going to go m units to the right and p units down, let's go y, if we go p units down, we're going to go plus p equals f of x. If I want to go 3 units to the right, I would have to go minus 3, but so I'm going to put an m there instead. Yeah. So give yourself a little, like if you can't think of it with in terms of m and p, give yourself a number, right? Like how would I write this? Okay. Is there one more way to write that? You could kick the p over, right? But we'll just leave the p where it belongs. Okay. Turn the page. Okay, now they're actually going to make you do this a little bit. This is very hard. The next part's kind of important. X minus 2, you're going to do exactly what it says. That's a horizontal translation, 2 units to the
Right.
to the right. Yeah, just move everything over. So you can even, like if you're a person that likes to take little points, just go 1, 2. 1, 2. You know what I mean? It says where? And you can just move them all over. You know what I mean?
Yes.
So,
Now we connect the blue dots.
oops, I missed it, but that's what you do. Okay? Maybe don't put those other little dots there. And you just literally go 2 over. Okay. And on this one over here, we have to go 2 places, right? We have to go down 2 and left 3. Okay, so take every point and go down 2 and left 3. So we're going to go 1, 2, 1, 2, 3. Okay, that's a big point. And I'm going to take this point right here. It's hard because I'm trying to, I'm going to go down 2 and over 3. So count 1, 2, 1, 2, 3. There's the big point. Get the point? Get the point? And then I'm going to go down 2 over 3, 1, 2, 3. So I'm starting to get this picture, right? And I'm going to take this point up here. It's hard because you can't see where I'm pointing, but I'm going to go down 2 over 3. And then you can kind of know that goes over 2. I don't need to count that space, right? And then it goes, I'm going to take this point, I'm going to go this last point, I'm going to go down 2 over 3. Does that kind of make sense? So you can take every point, you can kind of see some that you could do quickly because it's nothing got stretched, it just got moved. So the same picture should be there when you're done. Okay, now this is kind of important down here. That was easy. There are two different notations. One is replacement notation and one is mapping notation, and they are different, and you need to know the difference between them. So do not confuse them. What we had done before, when we did this kind, and we're talking about in the function, okay, we're dealing with the actual what's in the function. We're not talking about a point. We're talking about what we're going to do with the function. We call that replacement, and we write those kind of examples. That is not the same. Okay, well, I'll finish reading this. Under this transformation, all points in the graph move 3 units to the right and 2 units up. We knew that. 3 to the right, 2 units up. Okay, the point with coordinates 4, 6 will be translated to the point 7, 8. 3 to the right, so we're going to add 3 to this one, and 2 units up. So we get from 4, 6 to 7, 8. Y'all good? Keep following. In general, the coordinates of the point x, y is translated to the point here. Okay, now this is point notation that we're going to call mapping. Okay, mapping is when you take a point and you tell what to do to it. That's called mapping. It is not to be confused with what we do when we do this kind of stuff. That is called replacement. Do you see that? Mapping is from a point, when you're given a point and you tell what to do to it, and replacement is when you're talking about what you're going to do to the function itself. Okay, so just a technicality there, but it is important. Okay, so notice this is one is important. The mapping notation of the point is equivalent to the replacement notation of that. Because what we do to the function is actually opposite of what we do to the point. Maybe? Sort of? Okay, so let's just do this last example. And then, to state the coordinates of the image of the point -3 and 5 under the translation described by this. Okay, so this is the point. So this is actually what happens to it. We do these exact things. So we go -3 and we -7 from it. And we take our 5, which is our y value, and we add 4. So that's what you actually do. And so that becomes, where am I looking? -10 and 9. Okay. Now it says, write the equation of the image y equals f of x after the translation of that. Okay, so this is what's actually happening to the point. So when I want to write it into my function, I have to do the opposite. You with me? So I'm going to go y -1 is equal to f of x plus 6. You follow? Because this is where the point is actually going, and we know that that's actually backwards when we look at that function. Okay, that's the end of that lesson. Just go forward a couple pages, and we'll pick up the next lesson. Okay, so lesson 2 is exactly the same thing. We just get a little more complicated in our functions. So if you look here and you go on down, you've seen this page so far. You've already seen that. So when we go down here, they just want you to write the replacements. We just talked about replacements versus mapping. And here they actually want you to write the replacements. So all they want you to do here is say, this 3 is actually with the y. I'm going to write it over here. So my replacement was that y got replaced with y -3, which means it's a vertical translation 3 units up. Okay? Just exactly what we just did. All right, on B, note this. They want to say, they want you to compare how this one relates to this one. Right? So all we need to say is that x got replaced with x -1. So the second box would be a horizontal translation, 1 unit to the right. follow me? Okay, letter C. All right, what happened from here to here? Well, X got, okay, yeah, X got replaced with X. Okay, to go back to B, we have to write what happened to Y. No, there was no translation from this first one to this one. They just want to compare the two functions together. So here, though, on letter C, we have two movements, right? We have a horizontal movement with the X minus 6, and we have a vertical movement as well. So we can go, I guess the book really wants you to put that Y value over on that side. So maybe we'll go Y minus 2 is equal to the absolute value of X minus 6. Okay, so X got replaced with X minus 6, and Y got replaced with Y minus 2. So let's do horizontal translation. 6 units where? To the right. Minus space, and then there's a vertical translation, 2 units where? Up, correct. So they really want you just to be consistent. If you always put the value, the horizontal value over with the Y, then you can do the opposite of those things every time without even thinking. I think that's why they want you to do that. Okay, letter D, just to compare those two together, X got replaced with X plus 1. So that is a horizontal translation, 1 unit to the left. Yeah? Okay. And let's go down to class example number 2. Write the replacements for X and or Y, and hence the equation of the image. Okay, not just the where did it go, but actually write the equation. So write the translation first. If it goes 3 units to the right, then X, it's a horizontal, so we're going to talk about the horizontal. X gets replaced with X minus 3, correct? So my new function would look like this. Y equals X minus 3 squared. And on letter B, it's a vertical translation, so that's a Y. And it's 2 units up, so I'm going to say Y is going to go Y minus 2. So my new equation will look like Y minus 2 equals 10 to the X. Or you could write it like this, Y equals 10 to the X plus 2. And letter C says Y equals the square root of X after a horizontal translation. So write that down right now. So horizontal, I'm going to go X is going to go to 4 units to the left, means X plus 4. And a vertical translation, Y is going to be replaced with Y 3 units down, means plus 3. Always just do the opposite. So my final answer is Y plus 3 is equal to the square root of X plus 4. Good? Okay, turn the page. Okay, function represented by the thick line is a transformation of the function represented by the thin line. So the thin line has been moved. Write an equation for each function represented by the thick line. So what did we do with the little line to make the thick line? What do we do? I pick a point. I say, what happened to that point? We went 2 units to the right. So write it down. And then we went 1, 2, 3, 4 units down, right? So all we have to do here is write the function. So Y, what are we going to do here? Plus 4 is equal to the absolute value of X minus 2. Let's rewrite that just because we know we can. And we'll just kick the 4 over to the right. Yeah, you good? This is about good. So we're almost done. Then we're going to go this one. What happened to it? So these values, the thin line on letter B, the thin line went where? Kind of hard. Pick a point, I guess. So it went 1 to the right and 2 up. Would that be correct? 1 to the right and 2 up. So I'm going to say, okay, to the right, I'm going to go X minus 1 down there with the X. The X got replaced. And then 2 up. I can just go plus 2 there on the end. Done. Any questions? Looking good, right? Okay, let's go down here to C. Thin line went to the thick line. It didn't go left or right at all. It just went down. So I can say y equals f of x. And I'm going to go down 1, 2, 3, 4, minus 4. That one was super simple. And the next one, it went to the left and up. So y equals f, we're going to make it move to the left. So x plus 3, correct? It's the opposite direction. It's the opposite sign. And then we're going to go 1, 2, 3, 4, up 4. Done. Okay, one last thing and I'm done. Y equals the square root of x is a radical function. That what vertical translation would be applied to y equals the square root of x so that the translation image passes through the point 16 and 7. So what they want you to do here is say we're going to do something to the vertical, to the y value. So we can start like this. We can say, okay, something's going to happen to that y. I'm just going to call it a k. That's all that's going to happen. It's going to be a vertical move. So they just want to know what k is. What's the value? It just says what vertical translation, so that's the only thing I have to worry about. So you just got to find k. So you just plug in 16 and 7 for x and y and find k. So I go 7 minus k equals the square root of 16. You can subtract 7 if you want and get negative k is equal to negative 3, so k is equal to 3. So do you know where it went? You would end up with plugging that into this if you wanted. So what does the 3 do to it? Was it up or down? Up, correct. So 3 units up. That's the answer you want to give. All right, similarly, let's do the same thing, but it's a horizontal translation. So you can see. So it's a horizontal translation, so I know that I'm going to change the x value. So I'm going to say y equals the square root of x minus, I think they call it h. And I would put that, yeah, they do call it h. I like to put that in parentheses, just so you understand that it's all together. And then you just got to plug in your 17 for your x, and your 8 for your k, or for your y. Do the math, square both sides, and you get 64 is equal to 17 minus h. Subtract your 17, you get 47, and then flip your negative sign over. There's your h. So what does that mean?
Moves to the right.
Oh, okay, now, wait, let's go plug it back in our equation so we have a good look at it.
There's to the left.
Yeah, so we're going to go like this. The square root of x minus a minus 47. I think this really helps. So then you get y equals the square root of x plus 47. You with me?
Yes.
So actually it's 47, horizontal translation, 47 units to the left. Yeah. So you might have to plug it back in just so that you're comfortable with the negative part and you get that right. Okay, that's all I've got to say. Good luck. Do all your homework. Sounds good.
Can I leave?